Hey everyone, this is Paul Duvall. I'm founder and CTO of Emphasis Stelligent. I gave this talk at the AWS New York City Summit in 2019, so just sharing this as a screencast as well. So at Stelligent, we've been helping companies apply DevOps practices on AWS for over a decade now. So what I'll be sharing here is really based on that perspective. And when you think about encryption is about protecting your data from unauthorized access. So you're going to learn how to apply encryption in a practical way and doing that through automation. But before we get into this, I want to share a perspective on what we often see when it comes to security and compliance in general at most enterprises. So what we often see is that security is something that's the responsibility of a separate team. Or it might be multiple teams that are further downstream in the software development lifecycle. So if you imagine you have a development team and they're writing code, they're writing tests, maybe they're performing continuous integration. They might be doing this over a period of a few weeks or so. And then the teams, they're ready to release. So let's just say it goes to QA, might go to a change advisory board, internal audit. Some cases it might go to a separate security team that gets involved. And the problem is that there's often a significant amount of time between, say, when a developer commits the code and then when there might be any kind of security and compliance checks that are applied, that are comprehensive in nature. And so even if there are some security and control directives that are well documented, it doesn't mean that they're always run for every release and doesn't mean that they're run the exact same way every single time. And then there's also the fact that it could be weeks before the developer made that change and the developer's going to lack context if security brings it up, and there's going to be a pressure to release and things like that. And the reason this occurs in many organizations is because of the cost as the result of the process that might require human intervention, even if it's just one thing that they have to do. So they often get batched and they get scheduled across all the different application service teams that these central security operations audit teams have to support. And another reason, when you think about it from an AWS perspective, because you can automate all these things, there might simply be the lack of knowledge that you can automate those. So it's not just sort of the old style data centers, non-cloud types of companies, but even companies that are using AWS might lack the knowledge that, hey, you can actually just check a box or you can automate this through the SDK or through CloudFormation. And so as Werner Vogels talks about, the bottom line of all this is that security is everyone's job. And the beauty of this now is that AWS gives you the tools to bake the security and the compliance into every step of the software development process. So from the standpoint of encryption, you can automate all the encryption as a part of your software development process. You can also automate things like static analysis checks and runtime checks against your software in order to ensure that you're always in compliance with your encryption directives. And so, as Werner also says, you can dance like nobody's watching, but we encrypt like everyone is. And AWS announced, and this is as of July 2019, that 117 AWS services now integrate with KMS, and that's about 175, 180 total services. So much more than half of the services provide that capability. And so these might be storage services, S3, EBS, your database services like RDS and DynamoDB. And the plan is to eventually have all the services have this capability. So in terms of what I'll be covering, we'll be talking about how do you automate all this, right? How do you incorporate this into the software development lifecycle? How do you use things like AWS CloudFormation? How do you use the SDK, or how do you get access to the API ultimately in order to make this a part of that software development process? When developers need to apply things like client-side encryption, or they need to manage secrets, things like that. So we'll go over that a little bit in terms of client-side encryption. And then once you need to send that over the wire, you need to encrypt in transit. We'll be talking about things like AWS Certificate Manager and CloudFront, along with ELB. And then how do you encrypt that data at rest, either through database services like RDS and DynamoDB, EBS, S3, and so forth. And then the underlying service that allows you to encrypt all these capabilities is the key management service. So we'll go over that, and also how to give fine-grained permission to keys and fine-grained permissions to the service itself. When it gets into production and you want to detect whether or not encryption is enabled or not against all your AWS accounts, we'll cover AWS config rules and CloudWatch event rules as well. AWS provides, just recently announced that they provide encryption over a VPC for certain instances, the Nitro instances. So we'll briefly cover that. And then finally, we'll talk about logging. You can log all of your API calls, but then from an encryption standpoint, how do you know when those keys are used? And then any of the mitigations that you might have to go through as a result of that monitoring and logging. So there's a heuristic that we use when we look at really anything that we're building and deploying, testing and releasing into production. And there's 3 steps to this. And the first is to codify all the things. So whether it's an AWS service, if it's application code, configuration, infrastructure, or the data, we can codify all that. And we can use things like AWS CloudFormation to automate the provisioning configuration of these services, whether it's a database or storage, or it's the pipeline itself, containers, things like that. How do we codify all of that? And then the next thing we consider as a part of this heuristic is, and then how do you create a pipeline out of it? So not just how do you code it and version it, so how do you put it through a series of stages and actions in which you're building, testing, deploying, ultimately getting out to end users. And end users might not just be end users of the services and applications that your customers consume, but it also might be internally within AWS, and say some of the security services or even AWS accounts. You might put that through a deployment pipeline as well. And the last part of this is then how do you secure it, right? So how do you ensure that security is run as a part of your pipelines? How do you ensure that you have security of the pipeline through hardened build images, and that you're ensuring that everything goes through the proper checks? How do you give fine-grained permission to all the resources in your AWS accounts? So these are the 3 steps that we consider. And from an encryption standpoint, we're going to look at how do you codify that encryption? How do you put that encryption through the pipeline? And then how do you secure that? So let's take a look at a brief example on doing this from that automation lens. And so AWS CloudFormation is the service that allows you to automate that provisioning. So let's imagine you have a bootstrap template that you create a stack out of. And so you have sort of the core, you might be running this from the command line. So you have some of the core services that you want to have set up, whether that's KMS, the key management service, AWS config rules and config, and identity and access management. And then finally, the pipeline itself. And then that pipeline itself, you can put various different stages and actions and services that you might be automating as a part of that. In this example, let's imagine that we have the directive is that we want to have encryption enabled for all of our services. And so we're going to look at that from a couple different perspectives. One is every time you build part of their software system, you want to make sure that you're not going to introduce any security vulnerabilities. In the context of encryption, we want to make sure that anything that we build that needs encryption has encryption turned on. And so we can use a static analysis tool like CFNAG, which is an open source tool that has 45 built-in rules to it. And you can look for encryption on certain AWS resources. And if it doesn't have that encryption, we can fail the build, give notification. And before we even launch the infrastructure, we can have a remediation to that and commit it back to the version control repository, and then we're on our way. But then we can also set up detection controls as well, automated detection mechanisms, and we can do that through AWS config rules. And AWS config notices any state change to a number of different resources in your AWS account. And so we could set up a config rule that looks for changes to, say, your DynamoDB tables or your RDS databases, or ensuring your EBS volumes are encrypted. So we can do that from a static perspective as part of the pipeline, but then we can also set up these, we can automate the provisioning of these resources and deploy these rules. And under the hood, these rules are running these checks in something like AWS Lambda. We can write that in a number of different languages, Python, Ruby, so forth. And then we can run this based on schedule or based on whatever the event is. It could be based on schedule, could be based on whether there's a state change. And then we can perform some remediation action based on that. It could be to Slack the developers and say, you want to automate this and here's how you automate it. Or it might be to disable that resource or to automatically say turn encryption on, if that's the rule that we're looking at. So that's a kind of an overall view of how you might do this. So let's get into the first part of this, and that is automation. So automation is provided in a number of different ways on AWS. So AWS CloudFormation provides this common language. You can define it in JSON or YAML, or you could have higher level tools such as the AWS CDK, the Cloud Development Kit, that generates CloudFormation templates for you. But this way you can define this in code. You can define this in a template. You can version. You can test the CloudFormation template itself, just as you would any other software asset. You can also use SDKs. So there's AWS SDKs for all the common languages that are used, whether it's JavaScript or Java or .NET or Python, Ruby, so forth. Any of the Go, any of those common languages that you might be using. You get access to all the API as a result of that. And CloudFormation provides support for most AWS resources. And so from an encryption standpoint, primarily you'll see some of these examples. There might be a property like a KMS key or SSE encryption, server-side encryption that you can turn on. It's just a property, Boolean, you make true, and then you're on your way. You're able to automate that process. So it's great to have that checkbox in the console, but if you want a repeatable, testable process, then AWS CloudFormation is one of the great ways of doing that. So this is this is nothing to do with encryption. It has to do with more about CloudFormation, just to give you a high-level view if you haven't seen it before. You have things like parameters and resources and output. These are some of the common constructs that you'll see in a CloudFormation template. And so you generally will see multiple parameters that you'll be able to provide to customize the behavior of the stack that you're going to create from this template. And then you might have multiple resources. Typically, you're going to see a CloudFormation template might have hundreds of lines of configuration code. But it's declarative in nature, and so it determines how it applies these changes, and you can set dependencies and things like that. It can definitely get more complex than the simple example that you see, but the idea is that you can define all of your AWS resources in code using this CloudFormation language. So from a development standpoint, especially when it comes to encryption for client-side encryption, AWS provides the Encryption SDK to support client-side encryption. And it provides support for a number of different programming languages like Java, C, Python, and provides CLI support so you can really run it with any language that you happen to be using. The other service that you come across as a developer is you often have the need to store secrets somewhere, and that could be the username and password for a database. It could be API keys and so forth. And the Secrets Manager is a fully managed service that allows you to create these secrets, generate random secrets, and provide cross-account access. And then it integrates with a lot of or at least a number of the different services. So, for example, it integrates with DynamoDB and RDS and Redshift automatically. So you can generate username and password randomly, never even see it, and rotate through that automatically using the Secrets Manager service. And we'll touch on this a little bit later when it comes to management as well. And so this is an example of using the Encryption SDK, and this is a Python example in which we're taking some plain text source data. We want to encrypt it, and then we can so we convert it into ciphertext, and then we can decrypt it as well. And one thing to note, when people look at encryption, they always kind of think back to decades ago when there was such, there's 20 to 40% hit, say, on your performance. And with the use of KMS, there is not that performance hit. KMS actually performs the encryption, so you don't have the hit on the service that you're using on the compute side, the database, or whatever you happen to be using. So keep that in mind when it comes to encryption, because often people believe that there's a performance degradation, and that's not the case. So we've talked about encrypting on the client side. Then when we send over the wire, so in transit, we want to have the capability to secure the connection between the end user and the endpoint that they're hitting. And AWS provides a number of different services around that. One is the AWS Certificate Manager, or ACM. And what this does is allows you to generate public certificates, part of a certificate authority. And it also rotates that certificate for you. And so you don't get into the bind of, say, having a certificate that expired, and then that means your website's down. And if you've ever been through that before, you know the troubles that ensue as a part of that. And so it manages a lot of that for you. It's freely available. There are 25 certificates that you can apply to an application load balancer. Another service in terms of in transit that's really useful is CloudFront, which is a CDN, so it provides the performance, caching, things like that. But what it also does is it gives you access to AWS Shield for volumetric DDoS protection. And so, and you just get that built in with CloudFront. In fact, if you take a look at the well-architected framework in the security pillar, in that they go over some examples in the GitHub repositories, some quick starts. And so they have some CloudFormation code and so forth, in which it uses CloudFront with Certificate Manager. And you can get all that set up in really less than an hour. So definitely have a look at that. So this is a simple ACM example in CloudFormation, in which we're generating a certificate against our TLD, against our top-level domain, which is example.com. And so you can see it's pretty simple to set this up. So, we're assuming maybe you created the domain using Route 53, and you've set up your DNS, and you have a certificate. You attach that certificate to your load balancer, CloudFront, what have you, and then you're off and running with this CloudFormation code. And the endpoint could be any number of things, but in the case of encrypting in transit, we have this example where you're hitting a website. And so when we go to this website where we see the lock, and we can look at more information as well, but we know that there's this certificate authority that's identified that the connection between the end user and this website has been encrypted, so it's secure in transit. So at rest, how do we encrypt at rest? And there's a number of different services of those 117 services that help you encrypt your data at rest. One is EBS. And in fact, recently, EBS now provides the ability to encrypt your volumes by default. So all the volumes that you create with EBS, or you can select them one by one to encrypt it. But again, basically, it's pretty much a checkbox for all these. You have a KMS key, and you can associate that KMS key with that particular service, or with that the resource in that particular service. Other ones are RDS and DynamoDB. We'll take a look at an example of DynamoDB in a moment. And then Amazon S3 for object storage. You can encrypt that on the server side as well. And so the underpinnings of all this, as I mentioned, is the key management service, which we'll get to in a moment. But that allows you to create and manage these keys and rotate them and things like that. But what we're doing is we're creating these keys and then attaching that key ID to the resource of those particular services, so that we're able to encrypt our data at rest. And so here's an example of encrypting data at rest in CloudFormation for DynamoDB. And so we have a DynamoDB table resource in CloudFormation. We have some of the other properties and attributes that we're specifying, but the one here, we have the SSE specification where we have a Boolean, we turn that on, and now for this particular table that we've defined using CloudFormation, we have encryption turned on at rest using this property. As we discussed, you could have a checkbox, but what this allows you to do is make that part of the software development process and codify it. And then you see the results of that in the DynamoDB console. So all this, the underpinnings of everything I'm talking about from an encryption standpoint is the key management service, or KMS. And you can create and manage these keys, what are known as customer master keys. There are some built-in AWS managed keys for specific services as well, S3 and others. But you can also create your own CMKs, these customer master keys. And these customer master keys then allow you to generate data keys. And then with these encrypted data keys, then you can encrypt the plain text for any of the services or any of the data that's used by some of the services that you need to encrypt and that provide that support, that have KMS support. You can also get fine-grained access through something known as a key policy as well, and you'll see an example of that. The other ability you have is automatic rotation. So you can check a box, or you can automate it, of course, but you can check a box in KMS to say, I want annual automatic rotation of this particular key or these keys. And then for fine-grained access to the KMS service itself, we can do that through Identity Access Management Service, through IAM. And then the other service is AWS Cloud HSM. And so this is a cloud-based hardware security module. It provides asymmetric encryption, and it's single tenant. And so if you look at KMS is symmetric encryption, which means that you're using the same key to encrypt and decrypt. With asymmetric encryption, you're using different keys on encryption and decryption. Use the same math, but different keys. Both are FIPS 140-2 compliant. This is the NIST standard that it adheres to, but KMS is level 2 of FIPS 140-2. And then Cloud HSM gives that extra level when it comes to asymmetric and using the single tenant hardware security module. It's level 3, and then KMS is multi-tenant. And then we touched on these before, but you have Secrets Manager, which enables you to create these secrets across all your services. You need state for these services. You can use the Secrets Manager for that, rotating these secrets, generating random secrets, giving you cross-account access to these secrets as well. So here's an example of defining KMS, a KMS key in CloudFormation. I'm able to enable that key rotation. Talked about that. You can checkbox, but in this case, we're defining it as code. But enabling key rotation means this custom master key that I'm creating here will automatically rotate once a year by doing it this way. I can also set the pending window for deletion. So if I want to delete this key, I can set anywhere from 7 days to 30 days, 30 days being the default between the time where I disable a key and then when that key automatically gets deleted. And this just gives us time, because once a key's gone, it's gone. You can't use it. If you created a key, you attached it to a resource, and that key ultimately gets deleted, you're never going to get it back. So it gives you a window to make sure, and we'll talk about how you can find the use of your KMS keys using CloudTrail a little bit later. So the rest of this is that key policy I talked about, and this is giving fine-grained permission on the key itself. Identity Access Management gives you fine-grained permission on the use of KMS, and then this gives you fine-grained permission on the key here that we're creating in CloudFormation. So this indicates which IAM user has access, and then the second policy allows administration of this key, and then lastly, the use of that key is defined as well. And you can see how you're able to define the principal and which actions they're able to create. There's actually a number of other actions that you're typically defining in your CloudFormation template. And then you see that in the key management console. And so if I went over to, say, the key rotation tab, I would see a checkbox there that would indicate that it's automatically being rotated. So mention how we can statically look for whether or not encryption is going to be enabled, at least from an automation standpoint, through CloudFormation and tools like CFN-NAG. But from a runtime perspective, how do you detect these changes, or how do you detect that encryption may have been turned off? And so you have the directive that everything needs to be encrypted, but maybe it didn't get automated, or maybe someone turned it off after it went into production. Well, you can have these detective controls in place using something like AWS config rules. And config rules notices any state changes, And in the case of encryption, let's imagine that someone turned off or never enabled encryption for DynamoDB. It notices that change, and then you can configure it in such a way so that it runs through some kind of remediation workflow. It might Slack the developer, let them know that how to codify that. It could automatically enable it, or it could just disable that resource altogether. At least maybe give some kind of warning that'll let them know that they won't be able to use that resource if it's not encrypted. So there's lots of different ways you can do this, but ultimately, these config rules are defined in AWS Lambda, and so you can write your own custom rules. But then there's 86 managed rules that config rules comes with, of which 6 are encryption related. So if you want to extend that to say all the AWS services that KMS supports, you could do that through the custom rules. And then there's some other services that are relevant as well. CloudWatch event rules gives you this near real-time stream of events, and so you can perform actions based on that. And Inspector also helps you from a detection standpoint as well. And so here's an example of defining a config rule. We're provisioning this config rule in AWS CloudFormation. We're using one of those managed config rules for encryption, and this one is saying that we want to make sure that any CloudTrail that gets created needs to have encryption enabled. And if it's not, it's going to let us know. And then we might have a workflow process, as I talked about before, in terms of auto remediation or notification goes through a knowledge base. However, we decide that the best way to inform and be responsive to developers in terms of what that directive, the overall control directive is. And then we see the config rules dashboard that lets us know that we are not compliant with the particular rule that we've set up. On the networking side, just to touch on this a bit, but AWS announced encryption across the VPC for all its new Nitro instances. And then you can also encrypt between your data center and AWS using AWS VPN. You can define that in code as well. So lastly, we want to talk about logging. So AWS CloudTrail logs all API calls, not just security and compliance and encryption, but it's going to log all the calls that you make to the AWS API. But when it comes to encryption, what CloudTrail helps us with is the use of, say, the key management service or Cloud HSM. It's going to notify us when particular keys are used. And this becomes useful if, say, you want to disable a key and you want to know which users are using that and how they're accessing things like that. And then you can also encrypt the CloudTrail trails themselves. You saw that or at least the detection check for that. You saw that in AWS config rules. And then here's how we do that. In CloudFormation, we're defining the AWS CloudTrail trail resource, and then we have a KMS ID. So you might imagine that maybe elsewhere in this CloudFormation template, we've automated the provisioning of the KMS key. Then we've automated the provisioning of the AWS key KMS alias, and that's what we're referring to here. So the alias points back to that key. Then we're able to use that key ID and attach that to this trail. We're able to enable things like log file validation to ensure that nothing got modified. But this is a way that we're able to encrypt that trail and then be in compliance with that directive, and then being in compliance operationally with that config rule that we've set up to run. And so this is how we're able to, this is a JSON payload from a CloudTrail trail, and we can see the KMS API action that get called, trying to decrypt. This is what time it happened against this key, against this EBS volume from this resource, and this is the user that was making that request. And so that can help us troubleshoot. It can help us if we're in a case that we need to disable a key. It'll give us some time to hunt down the use of that key before we actually go through that action. So overall, these are the takeaways. Don't write the crypto yourself. So AWS provides AES 256-bit GCM encryption. So you definitely don't need to write the crypto yourself. If you want to look at the third-party attestations in terms of SOC compliance and the FIPS 140-2 standard, PCI, and so forth, you can actually use AWS Artifact for that if your auditors are looking for that and you have that requirement. but you have that level of trust to know that a third party has looked at this and they understand how the service works and within the AWS data centers and so forth. The other thing we went over is how encryption becomes part of that software development lifecycle. You can use CloudFormation, you can use other tools for that. You can build in static analysis checks to ensure that encryption is occurring prior to launching the resources as a part of your software system, as a part of your infrastructure. You can automate all these things as a part of a deployment pipeline. You can get encryption in transit through the use of CloudFront, through the use of the AWS Certificate Manager to get that transport layer of encryption. With CloudFront, you can integrate that with AWS Shield to get that DDoS protection. Of course, KMS is the underpinnings of all this. KMS allows us to create keys and delete them, grant access to them, get the fine-grained permission. You can rotate keys. You're assured that it doesn't go outside the hardware security module on which it's running. You can also use Secrets Manager to store secrets for things like usernames and passwords, things that you need state for and you need to have encrypted. It will perform the rotation for you, allow you to generate random secrets. Likewise with ACM, if it performs this certificate rotation as well. We can also run detective controls for runtime. Checks for encryption using AWS config rules or CloudWatch event rules. But that, once it gets in use, whether it's pre-production or production, we can run those checks to ensure that we're always in compliance. We can use CloudTrail, and we can encrypt the trails out of CloudTrail, but we can also monitor key usage to ensure that we know how the keys are being used and any actions we might need to take before, say, we delete a key. And then finally, when it comes to internal or external audits that you need to perform, if you're able to build this all into your end-to-end software development lifecycle, makes that whole process easier. You're always in compliance with the directives that you have in place. You're always in compliance with any of the compliance regimes that are out there, both of the cloud that AWS provides, but also inside the cloud because of the services and the way you're able to use these services as a part of your overall software development lifecycle. So thanks very much. You can reach me here, both on Twitter, and you can reach me at the email address. And if you have any questions, feel free to reach out to us at Stelligent. Thanks very much.